Source transformation converts a voltage source in series of a resistor into a current source in parallel of a resistor. When we apply the source transformation, we need to specify the terminal. So this terminal, this is the same terminal A, same terminal A, same terminal B, the same terminal B. Either is connected this way, a voltage source in series of a resistor R, or current source in parallel resistor. They are exactly the same in terms of this terminal A and B. And this is both ways. We can transform from this direction to this direction, or this direction to this direction. That's both equivalent. The detailed derivation for the source transformation are not going to be discussed here for the time purpose. We're going to apply the source transformation in the analysis of the circuit. What's the relationship of Vs and Is? That's this relationship here. If we do conversion from the current source to the voltage source, then Vs equals to Is multiplied by R. If we want to do the transformation from the voltage source to the current source, then Is equals to Vs divided by R. This is the source transformation. And also another important thing when applying source transformation is the sign of the voltage and also the direction of the current source. The sign of the voltage source, if it is determined this way here, and when we do transformation this way to the current source, the current direction has to flow up in the up direction. The idea of source transformation can be applied to the controlled source as well. There's a voltage source Vs, but it's controlled. And pay attention to the sign here. This is positive, this is negative. And in series of a resistor here. And this can be transferred to a controlled current source in parallel to the same resistor, same value R. The direction of the current flow up. The sign of the voltage, it has to mark this way, positive and negative. This is an example where we apply the superposition theorem, how we can utilize the source transformation to obtain the voltage VR3. First of all, we want to recognize, is there any voltage source in series of a resistor, or if there is any current source in parallel of a resistor. In this case, we only found a voltage source in series of a resistor. So using the source transformation, we can convert this voltage source in series of resistor, convert it into a current source in parallel of resistor. When we apply the transformation, we have to be a little careful. The first step we need to define is to find the terminal, which two terminals doing the transformation. And this is where a lot of mistakes can be made here. This is the terminal A, this is terminal B. So this is A and this is B. And this can be transferred to a current source that flow up to A. So this is R. And this is R. This is A and this is B. We have to apply the same rule here. And this resistor R1. So after converting, it can be converted into I'll draw it here, current source in parallel to R1. Current source current is V divided by R1. In this case, this portion is gone. I have the same terminal, this terminal A, this terminal B. Now it becomes a current source in parallel of a resistor. That's the same resistor R1, same resistor R1. So this is the source transformation. Now, if we look at this circuit, there's current source and this resistor is in parallel. Here are R2 and R3. We can obtain this voltage on R3 by analyzing this circuits very easily. Now we can combine this current source with this current source together, so we